Tonight, the universe stops growing. Every galaxy freezes at its current distance. Nothing collapses, nothing explodes. The expansion simply switches off. And here's what makes it strange. You'd never know. Not tomorrow, not in a year, not in your entire lifetime. Not because the change is small, but because you're standing on something expansion never touched in the first place. It would take millions of years for the first clue to arrive. And when it did, it would come as light. Let's start by clearing up the biggest misconception in cosmology. The universe expanding does not mean galaxies are flying outward through space, away from some central point. There is no center. There was no explosion at a location. What's expanding is space itself. The distance between distant things increases everywhere, all at once, without anything moving through space to get there. The classic picture is dots on a balloon. Inflate it, and every dot moves away from every other dot. No dot is at the center. From any dot, all the others appear to be receding. And the farther away they are, the faster they seem to go. That last part isn't a metaphor. It's a measurement. In the 1920s, astronomers found that light from distant galaxies is systematically redshifted, stretched toward longer wavelengths. And the farther a galaxy is, the greater the stretch. That relationship is the direct evidence that space is expanding. Then, in the late 1990s, something unexpected turned up. Astronomers measuring exploding stars in distant galaxies expected expansion to be slowing down, dragged on by gravity. Instead, they found the opposite. Expansion is accelerating. Something is pushing it faster. We call that something dark energy. And the honest position is that dark energy is a name for an observation, not an explanation. We can measure its effects. We do not know what it is. So our hypothetical is simple. Tonight, whatever drives expansion switches off. Space stops stretching. Everything else, gravity, light, matter, behaves exactly as it does now. What changes? First, absolutely nothing near you. This is the part that surprises people most. Expansion isn't happening inside your body, your solar system, or your galaxy. Anywhere gravity is strong enough to hold things together, it simply wins. Atoms don't stretch. Earth's orbit doesn't grow. The Milky Way isn't inflating. Expansion only shows up across enormous distances, where the space between galaxies is vast enough and gravity too weak to matter. So switching it off changes nothing you could measure locally, ever. Second, our galaxy's neighborhood is already immune. The Milky Way is part of a gravitationally bound group of galaxies. That group isn't expanding. It's collapsing inward on itself. The Andromeda Galaxy is actually approaching us and is expected to merge with the Milky Way in a few billion years. Turning off expansion wouldn't stop that. Andromeda is coming either way. Third, the change arrives as light, very slowly. Here's where it gets interesting. If space stopped stretching, distant galaxies would stop receding. Their light would stop being redshifted by expansion. But we wouldn't see that instantly, because light takes time to travel. A galaxy 100 million light years away sends us light that's 100 million years old. So the news of the change would arrive as a slow wave, spreading inward from the nearest galaxies to the farthest, over millions and then billions of years. Astronomers would notice nearby galaxies' redshifts drifting first, and increasingly distant ones only much later. The universe would take longer to report the change than our species has existed. Fourth, the sky stops emptying. Now the genuinely important consequence. Right now, accelerating expansion is slowly removing the universe from view. Beyond a certain distance, space between us and a galaxy grows faster than light can cross it. Not because anything moves faster than light, but because more space keeps appearing along the way. Once a galaxy crosses that horizon, its light can never reach us again. Over hundreds of billions of years, this gets severe. Cosmologists expect that in the far future, observers in our merged galaxy would look out and see essentially nothing beyond their own island of stars. The rest of the universe would have receded past the point of visibility, and there'd be no way to know it was ever there. Stop expansion, and you cancel that. The sky stops draining. Distant galaxies stay reachable, stay observable, stay part of a shared universe permanently. Any civilization arising 1 trillion years from now would still be able to look out and see the cosmos, instead of concluding, reasonably and wrongly, that their galaxy was all there is. That's the real answer to this hypothetical. Stopping expansion wouldn't damage anything. It would preserve the view. Now the twist. Because there's a much stranger question hiding underneath. What if it didn't just stop, but reversed? If expansion halted and gravity took over, everything would eventually begin falling back together. Galaxies would drift toward one another rather than apart. Their light would shift blue instead of red. Over an unimaginable span, the universe would contract. The cosmic background radiation would heat up as it compressed and everything would converge. A scenario sometimes called a big crunch. It's a real theoretical possibility. It's also not what current observations point toward. Measurements favor continued acceleration, not a future collapse. But the honest position is that we don't know what dark energy is, which means we can't be fully certain what it will do over cosmological timescales. And that uncertainty leads somewhere worth sitting with, because expansion isn't just a fact about the universe's shape. It's the reason the universe has a history we can read at all. Redshift is how we measure distance. Distance is how we measure look-back time. Every observation of the early universe, the cosmic microwave background, the first galaxies, the evidence for the Big Bang itself, comes to us because light has been stretched on its way here, carrying a record of when it was emitted. Expansion is the mechanism that turned the sky into an archive. Switch it off, and we'd keep everything we already know. But a civilization that arose in a static universe, having never seen redshift, would have a far harder time discovering that the universe had a beginning at all. The evidence would simply be missing, which means we're living in an unusually good moment. Late enough that stars, planets, and chemistry exist. Early enough that the ancient light hasn't been carried out of reach. The universe is still legible. It won't always be. So here's tonight's question. If you knew the view was slowly closing, that the sky is emptier now than it will ever be again, what would you want us to record while we still can? And who exactly would we be recording it for? Every question creates a new reality, and reality is just one version of the truth. Every possibility deserves exploration. The next one begins with a single question. What if? Subscribe and explore what comes next.